things like that. Can we write probability of class is 1 given x. Probability of class is 0 given x. We directly estimate the likelihood. Somehow, I will not use the notion likelihood here. I will say probability. Probability of so logistic regression. We have inputs, maybe 1 or 2, whatever, but the output target is binary. Given x, we want to estimate the class. So when target is discrete, then we say it's a classification problem. The topic is logistic regression. Why do we call it regression? For regression, target needs to be continuously. But keywords. So it's these are the 2 keywords we will use. This is you can write it here. I will use sigmoid. Logistic regression is regression in what way? Logarithmically. But it is still regression, right? How? What is regression? In one abstract short way, we can write regression as a summation, weighted sum. Inputs multiplied by corresponding weights, summed, give us y, the target. The weighted sum giving target, as long as the inputs are linearly combined, they are not, their power is not other than 1. If we square x, then it will become nonlinear. It will still remain regression, but non-linear regression. Linear regression is linear combination of weights and inputs. Up to this point, logistic regression will still be regression, a weighted sum. But we will make it logistic by inputting this weighted sum, let's call it z, into a function called sigmoid, and this function is 1 over 1 plus e raised to power minus z. So this transforms your weighted sum w transpose x or z is, it can be any number between plus infinity to minus infinity. Depending on the scale of x, it can range anywhere, positive or negative. But what this function will do is to squash this number into the range of 0 to 1. That's why we also refer to it as a squashing function. That transforms your weighted sum into this range. And so your weighted sum will have a center, right? Some value will be at the center, max value, min value for z. At the center, this function will map to a value 0.5. And the transition for the next value will have a bit more of what? What do we have on y-axis?
Probability.
probability of class Y being 1, given that we have some information about X. That is soft transition. If we want to make a decision on Z, being, let's say we put 6 here, so if we say more than 6, if suppose these are hours studied and this is the status, pass or fail, we collect a bunch of data points that are here, and we see that people who studied more than 6 hours, they pass. Who studied less than 6 hours, they fail. Then it's a linear decision. But somebody who studied 5.9 hours will be failing. And 6.1 hours will be passing. So 10 minutes difference will change the prediction, fail to pass, which is not smooth, right? Smooth function to have. So this sigmoid function, we call it sigmoid function, because its shape is like S, right? Looks like it's sigmoidal transformation of Z into the range of 0 to 1. We'll put this number in this range, and here we have directly estimated probability of target Y given X. If we have this probability and we have only 2 classes, probability of Y being positive class will be, if it is a valid probability distribution, then the 1 minus probability of Y given 1 given X will be the other class, right? Probability of Y being 0 given X. If this is probability, what is this? You take this formula and look at it. This is probability of positive class. If probability of positive class is 1 over 1 plus e raised to the power minus z, and probability of negative class will be
1 minus that.
1 minus that, and when you simplify that, you will see it is equal to this. Probability of positive divided by probability of negative class. You want me to do this? So 1 minus 1 over 1 plus e raised to the power minus z. This goes here. This is 1 over 1. 1 plus e raised to the power minus z minus 1. Right? 1 minus 1 plus, no, we don't keep this. 1 plus e raised to the power minus z. This cancels. And we are left with e raised to the power minus z divided by 1 plus e raised to the power minus z. And we can cancel this. This is, we are left with 1 over e raised to the power minus z. So we can write it like e raised to the power z, right? This term goes upstairs and becomes positive. So probability of positive divided by probability of negative class is equal to these two terms simplified. This equals to e raised to the power z. What do we call this? Probability of one class divided by probability of other class is it is odds. Odds of positive class are, let's say if it is 1.19, so odds of positive class are 19% more than negative. So the ratio of one class divided by ratio of the other class is odds. So e raised to the power z is odds ratio. If we take log of odds, then you are left with z. Log will cancel e, you are left with z. So your weighted sum is what? Log of odds. Given x, the log of odds, when we put our x in weighted sum and calculate z, this gives us the probability. But we can use the same to interpret our linear equation, linear formula, w transpose x. So w naught x0 plus w1 x1 plus w2 x2 is y. In linear regression, you are reading it like this: 1 unit change in x2, keeping all others constant, will change y as many times as w2. This is what you were saying. Now you will say 1 unit change in x2 will change the log of odds of y being in positive class as much as w2. The interpretation changes. The equation remains linear weighted sum. But this is very powerful interpretation now. You are explaining the effect of individual variable on target in terms of log of odds. 1 unit increment, let's say x2 is number of hours studied. 1 extra hour studied will change log of odds for passing. How much? As much as W2. 1 hour less studied will decrease your log of odds for passing. How much? As much as W2. Now we call it logistic regression. It is logistic because we are taking this number and putting it in a new space. It's like transporting it into a new space. The weighted sum transported in probabilistic interpretation, logistic, regression. Many times it's an interview question you are being asked, given the target variable, you want to apply regression, but the target variable is discrete. You need to identify the target variable is discrete, then you will do logistic regression. Now you can connect log odds with probability, right? Probability of class 1 and ratio of class 1 with class 0 is odds. Log of odds is your weighted sum. That's all. How do we estimate these W's is the next question. In terms of linear regression, we used least square solution, analytical, right? But in this case, we cannot. So we have two ways. Either we use gradient descent or Newton-Raphson's method that we will discuss shortly, that is iterative reweighted least squares.